right?
Whoa, sick tattoo. Where'd you get it?
Well, I go to this lady who does it out of her house.
That's so cool. I'll get in. Whoa, your tattoo is so cool.
Thanks, man.
What do you think is in tattoo ink? Like, what's the chemistry behind it?
I don't know. I'll have to ask my tattoo lady. Let's go to her house.
Yeah.
Oh, hey guys, what can I do for you?
Can you teach us the chemistry behind tattooing?
Oh, sure, come on in.
Okay.
Back to my studio. So, you're wanting to know the chemistry behind tattooing?
Yeah, show us.
Alright, let's look over here.
What is the chemistry behind tattooing? Alright, so before we can get into the actual chemical build of tattooing, you need to know what tattooing is. Okay, so what is tattooing? Honestly, you can't be 100% certain. Manufacturers are not required to reveal the contents, and also tattooings are not regulated by the FDA. They're also technically not inks. They're pigments suspended in a carrier solution. Okay, so tattoo ink is a pigment plus a carrier, which equals your tattoo ink. Okay, so what is a carrier? The carrier's role is to work as a suspension to keep the pigment evenly mixed. So basically what that means is its purpose is to keep the pigments evenly mixed and provide ease of application. It's also used to disinfect the pigment suspension to avoid infection and unwanted bacteria in your solution. Since tattoo artists are allowed to mix their own, it's important that they have a solid-based carrier that avoids infection. Some common carriers are water, which, as we know, is H2O, alcohol, glycerin, witch hazel, or a combination of these. Since they are allowed to mix their own and it is unregulated, they can do whatever they want as a tattoo artist. Okay, so back to our formula. We know it's a carrier plus a pigment to get our ink. So now that we know the carrier part of it, we're going to get into more of the chemical makeups of the pigments. The purpose of the pigments is to provide color for the tattoo. So these pigments are usually made up of organic mineral pigments or metal salts or modern industrial organic pigments. A few are actually vegetable-based pigments, and then some are plastic-based. The next two slides are going to show some of the pigment composition for each color. So on here you can see black, brown, red, and orange. As you can see, black is usually made up of iron oxide or carbon oxides. Not listed on this chart is blue, which is usually obtained with copper salts or cobalt oxides. So then you can see the red and the orange and kind of what makes them up, like the orange being cadmium sulfide and stuff like that. This next one has yellow and green, and white's not included on here, but white is usually obtained through titanium dioxides or zinc oxides or lead carbonate. Okay, so now we're going to talk about the chemical structures of these pigments. So, these next pictures show the common pigments along with their chemical structure. Pigments contain both organic and metallic elemental compositions. So in this one, this is actually red 210, which you can see here is a hydrocarbon, and then you have double bonds like here and here. So yeah. Okay, this one is orange 13. And once again, you can see that it's a hydrocarbon. You can see its double bonds again. And this hexagon shape is actually how you identify your organic compounds. So that's how you know that it's organic. This is blue 15. which is a little bit different from our other ones as it has more of like a square shape to it, and obviously you can see its little organic composition. And our last example is violet 1. So once again, you can see its double bonds, its components that make up its hydrocarbon, and its organic structure. Alright, so overall, the American Medical Association was able to determine the most abundant elements present in tattoo ink to be aluminum, oxygen, titanium, and carbon. Tattoos are injected into the dermis, or the second layer of the skin, which you can see in this picture. Here's your epidermis, and then here's your dermis, so it's just below the first layer. When these components that are like right here are injected under the skin, they become stable, and the tattoo is permanent.
Whoa, bro! Your tattoo looks sick!
Thanks, man. I'm so glad I found out the chemistry behind tattooing.
Yeah, me too.